Hi, my name is Jaswant, and for my class project in CSE 335, I created an app called HackHelp. So the main goal of HackHelp is to enhance the hackathon experience. Hackathons are mainly 24, maybe 48-hour competitions where students implement a project. These projects a lot of the time involve coding, and the hackathon itself a lot of the time provides some mentors that come out from different companies that can help you when you run into some roadblocks. However, my idea was that since there's so many proficient programmers in the room while you're working on your project, you should be able to send in a request and get help from someone around you that's really good at the topic that you're having trouble with. So the app will also allow you to find other hackathons that you can attend in the near future, and it'll allow you to look at who's currently at the hackathon that you're attending. In order to implement this and have multiple users seeing the same data at once, I decided to use Firebase, which is a real-time database that's cloud-based. So now I'd like to highlight some of the general views a user would see when they're using HackHelp. So first, they would see a sign-in screen where they can enter their email or their password. This is where Firebase authentication is implemented, so if the email and password combination doesn't match anything that's located in the Firebase database, the user will not be able to go further into the app. Otherwise, they can click Create Account, and they'll be sent to the Create Account view. Here they can select a photo from their library or take a photo with their camera for a profile picture. They can enter their name, email, password, and their skills. After clicking Create Account, all of this information entered, including their profile photo, should be sent to Firebase and stored there. Next, they can click on Done and return to the sign-in screen to enter their email and their password and sign in. Next, they'll be sent over to the current request screen. All the data in this screen will be visible to all the attendees of the hackathon. So it includes some very important information in each cell, including the requester's name and the topic that they're having trouble with. So from here, the user can also sign out, or they can click on this top right hand button that will allow them to go to the Create New Request view. Here, the user's profile picture and their name should appear, and they'll be retrieved from Firebase. And the user will not be able to edit either of those on this screen. All they will be able to do is enter a topic of their choice, a description of the problem that they're having. They can choose an image from their camera or their library. Maybe this could be a picture of some code or some hardware that they're dealing with. And they can also enter their current location. After clicking Create Request, they will see this request created alert, and then they'll be able to go back and their new request will be populated right here in the table view. So now, what I'd like to highlight is that this current request view has a tab bar at the bottom. This tab bar has 4 different sections. The first one is the requests, which we are currently on. Then it also has the attendees. So when clicking attendees, the user will be sent to the attendee view. And that's right here. From here, the user will be able to sign out from the top left-hand corner and reload the view. The view will consist of a table view with the name of each attendee at the hackathon and their profile picture on the left of that. Next, the user can click on the Profile tab. This tab will take them to the profile view, where their photo will be populated from Firebase and their name. They can also sign out from this screen. They can look at their skills and who they're currently helping. And this view is completely unique to every user in that's using the application. So a user will not be able to see any other user's information or change their information. It's all based off of who the app is currently authenticated for. Next, the user can click on this web view. This screen is mainly meant for users to find a new hackathon near them that they can attend in the future. It implements a back button and a forward button and takes them to Hackalist, where they can scroll through and see future hackathons. So now I'd like to go over my UML diagram and highlight some of the more important things from it. So first we'll start with this user object, which has a name, a profile pic, a username, and a password. And then we also have a request object, which has a requester name, a description, an image, a location, and a topic. So later on I'll be able to show you how this user and request data is stored specifically in Firebase. But otherwise, I have my main view controller. Whoa, sorry about that. So I have my main view controller that has general, view did load, segue functions, and even a text field return function. But one of the more important things from my UML diagram are these two lines. I just crossed one of them out, but they're located in almost every single one of my view controllers. So the first one is a Fire data snapshot, which can be seen right here. So all information that's read from Firebase is returned as a data snapshot. So including a Fire data snapshot NS object in each one of my view controllers is essential for me to be able to read from Firebase and use the information that I'm retrieving. I also include a Firebase database reference. So this is essential to storing information into Firebase. So I can create a root reference in my database and then create children for it. So I can access information from the users. I can also store information for each user. So that is both of those are located in every single one of my view controllers almost. I also use a UI image picker controller, and that allows me to get profile pictures and images for requests from the user, from their camera or their library. And lastly, I also have a web view controller that has a web view in it, and it also has the functions for a web view. So now I'd like to highlight some important aspects of my MVC architecture diagram. So first, let me begin with the view. And in my view, some of the most important aspects are displaying the list of requests in a table view, displaying the attendees in table view, and also updating the table view cells with the proper data. And having a Firebase real-time database really allows the table to be updated and making sure that everyone can see that data. Next, I would want to discuss the controller. And my controller plays a vital role in connecting this model and view. It sends all the new user and request data to Firebase, so it's all stored there. It also retrieves data for the view, so it can be displayed, and especially in the profile screen, this plays a huge role, because sometimes I will not want to display all the information like I do in table views, but I would want specific user information. Another big part of this is authentication, which can be done with Firebase authentication, and so I would not want anyone to be able to access the profile screen or anything like that unless they're authenticated specifically into the app, so that we can handle exactly what information they're getting. And now the most important part, I believe, is the model, and that includes almost all of our database storage, the Firebase database storage, and it has object models for the user and the requests. And one of the key parts about this is that the model must notify the controller when data changes. So I always want my app to be updated and showing the proper data to all users. So the limitations of my application can be broken down as UI limitations and detail limitations. So for the UI limitations, one issue with the tab bar icons is that they change size when clicked on multiple times. And so that's something I would definitely want to fix in the future. The detail views for the requests and the attendees are currently not implemented. And the request view I would want the request view to have color coordination. So this would let the user know when a request is currently being worked on and when someone is currently waiting to be helped. So I also have not implemented a hack ID. This would be this hack ID's main purpose would be for uniqueness of the application for each hackathon. So when a user signs into to Hack Help at HackAZ, they would only see the requests for HackAZ, and when a user signs in at Southwest Hacks, they would only see the information for Southwest Hacks. This would be another field that I would have to add into my database to implement. I would also want the users to be able to delete their account. I think that's definitely an essential part of creating an account in the application. You should have the ability to get rid of it, and so that's something that I would need to implement as well. So as I stated earlier, I wanted to discuss how this information is stored in my Firebase database. This right here is the root of my database. It has a child called request and another child called user, and each request has a unique ID, as can be seen right here. And then within each one there's a description, a location, a name, and a topic stored. Same with the users, and so it can be seen that these are stored in a JSON format, and that makes it a little easier to extract the data as well using API calls later on. Working on this application, I definitely learned a lot of new skills. I've never used a cloud database before, or I've never had experience with Firebase. So learning the basic setup of Firebase using Cocoa Pods was definitely beneficial, and I know I'll definitely use that in the future. I also learned how to store data into Firebase using the JSON format, referring to children within within the root, and also representing Firebase in a table view. So I had to retrieve retrieve data using the Fire database snapshot, and store all that information into separate arrays, and then display it all into my table view, which was quite a complicated process to wrap my head around. I also learned how to do user authentication, which will serve as a very beneficial tool in the future if I choose to create any other applications. One big thing I also learned was project planning and how important it is to have every thing documented and everything planned out from the start so that you can reach all of your goals when creating a project like this. I also wanted to highlight some of my future goals for this application. This idea, I think, could be very successful and used in many different hackathons. So in order to make this app very useful and be able to put it in the App Store, I want to implement the Hack ID as I mentioned earlier. I want to increase the efficiency of retrieving and storing data so it happens faster. And I also want to explore the option of using CloudKit. CloudKit or Amazon Web Services, anything like that to make sure that this app works the best, because essentially I want many people using it all over the world. And my next goal after I implement some of the things I wanted to implement, such as these, is to pitch this to potential hackathons. I was hoping to start at Southwest Hacks at ASU and to see if they would want to try implementing Hack Help at their next hackathon. So When trying to think of improvements for the class project, I couldn't think of much, mainly because I appreciated how the project was broken down into phases, and I think we were given enough time between each phase to implement it, and given all the resources to be successful. Dr. Balasuria and all the TAs were always available for help, and they even offered to set me up with former students who used Firebase so I could make my project come to life, and I really appreciate that. But that is my presentation, and I hope you get the chance to use HackHelp in the future.